Now, we have someone back. Welcome. All right, so I should probably go over those first two beforehand, right? Like, what in the heck, right? This is off of the first one, okay? Don't look at the second one out, because I don't want to, oh my goodness, I'm going to die, right? So this one is just right off the first page, remember? May, June 2002, okay? Remember, I can only write so high, right? So I might have someone come up here, and then I should probably do I and then double I again, okay? Because I know Ian he absorbed it all, and now he's just going to give us all the information, right? He's like, yeah, sure. So let's talk about some of these things. I wrote some of this stuff here as well. I tried to give you guys a little bit of the board, okay? We're going to be doing complex numbers. This will always be up there. I might erase a little and put more in there for you guys later, all right? I'll try. Because it takes me a little while, because if it gets really thick, that's my right hand. And the higher it goes, it's my right hand. Sorry, I'm not a righty. So it takes me okay, so you get the idea. All right, so the first one here, it says about the complex number here, right? And complex number is a real number with an imaginary number, right? Yeah, that's fine. Here we go. I'm going to just use this little section here, okay? We already did this, but we're going to go over it, okay? And I'll help not only Sophia, but everyone else. So remember, I go C for complex. It could be U, V, W, it doesn't matter. Remember it says U here? Why, not you, but me, right? 1 plus, I think it says I root 3. Now, they like to put the root 3 on the other side, but it doesn't matter, okay? Now, they said that, hey, you got to find out when R is greater than 0. R will always be greater than 0. Why?
Can't be negative?
That's right. Can't be negative, and it's the hypotenuse, right? And if it's the hypotenuse, right, remember we did this?
Mm-hmm.
Cheesy picture?
Yep.
That's my R, right? And it's the same thing as the magnitude of Z, okay? Now, I know that's a lot of stuff, but we're going over it again, so just to reiterate, right? And then it does this other one, which is called Demoivre's theorem. We'll get that shortly. So remember, we're going to be talking about what's called the modulus. And don't worry, you can take a picture of this, okay? And then the other guy is, who has siblings? Yeah. Do you ever argue with them all the time?
Always.
I mean, like 10 seconds, you just want to... After about 45 minutes with my brother, I just want to give him so many lessons. Thanks for a ride, okay? That's my brother, okay? And he wants to go into teaching. He's a master electrician. He's like, fix your car, do whatever. You know, he looks at this and goes, no. But anything mechanical, he's just absolutely brilliant. And electrical as well. So he's now he's going into teaching. He's going to be teaching the prisoners. That's going to be fun. I did that for a year. Okay, so here we have this little triangle, no different than what you've seen before, right, in trig. Remember, this is Z is equal to X plus YI, and that's no different than this guy right here, or A plus BI for complex, right? Mm-hmm. That little point. And then we have the triangles that are shown right here. I have it here. So this side is R sine theta, which equals Y, right? And then this is R cosine theta. No different than you had, and that's X. You know, X, Y, and R, X, Y, Z. So the modulus for this thing is the same thing as the square root of X squared plus Y squared. Well, how do you get those points? Well, obviously, the X is the real portion, and the Y is the Fantasy Island portion. That's an old show in the 70s. Welcome to Fantasy. If you look it up and go Fantasy Island, Mr. Rourke, this guy's all dressed up in white, and he has this little cabana boy called, his name used to be Hervé Villachez, but Tattoo. And he goes to the plane, but so that's where it comes from. So all you have to do is go to the square root of what? Well, that's 1 squared plus the square root of 3 quantities squared, and this comes out to the square root of 4, which is a good old deuce. That is what's called the modulus. That is also the hypotenuse. Pretty review there, right? No different, okay? Remember, yes, ma'am?
So for the Z equals X plus YI, is that the point? Or
Yeah, that's where it is. Yes.
That's the point?
Yeah, that's the point. What's the point? Well, that's the point, right?
Okay.
It says, here's the point. Tell me how far it's from the origin, and then the angle where it is. Okay? Where it's shot from, right? We're trying to find, the killer of Kennedy, right? Mm-hmm. We start where the bullet happened, and now we're going backwards. Yes, sir?
The Z with the 2 lines around it, is that the same as R?
Yes, because I'm going back forth to polar as well as Z, okay? I want you to get familiar with it.
Okay, what's that called again?
Modulus.
That's the modulus.
What's in the square root?
Square root, this is the square root of X squared plus Y squared.
The next one.
This is the square root of 3.
Okay.
Okay? And remember, the square root and the radical and the square kill each other off, and it becomes 3, right?
Yeah.
1 plus 3 is 4, 2.
It's the Pythagorean theorem.
That's all it is. It's all it is, just in polar form, right? Now, I read something about Argonne if I get to it. He was a bookkeeper, and I'll get to this. All right, so if you see these little bars here, that means magnitude. So it's absolute value, it means it's the length. So it's the length or the magnitude of that guy.
That's why it's absolute value.
That's right.
It's greater than 1.
That's right. It has to be, right?
Yeah.
Anything, if it starts at the origin and goes forward, I don't care what quadrant it is, it's greater than 1. It has to be.
0.
Well, it can't be equal 0, then the radius is 0, right? Then it's in the origin.
Greater than 0.
Greater than
Yeah.
0, right? Always has to be greater than 0. I should put that up there as well. Okay? Yes. Okay, so here we keep going, right? So that's the modulus. Now it's your kids arguing, and that's the tangent minus 1 of y over x. Remember, that's theta, right?
Yeah.
That's the little angle. Sometimes I write phi, okay? Phi or phi. Phi, right? Okay? But you get the idea. Sometimes I write the, because that's where it's calculated, right? And then this is just going to be the tangent minus 1. I'm sorry to write so low because I'm short as well as hurt. This is going to be, remember, y is this coefficient in front of the imaginary number, radical 3 over 1. So now this is theta, right? This comes out to be, if you had your calculator, 60 degrees. But Billy's like, hey, we have to have it in radians, right? 2 possibilities, remember? So this would be, you divide the degrees by pi, and you get pi over 3. That's excellent.
Or you can
Or,
1.05.
yeah, how'd you get 1.05?
I just took.
I did the
what
calculator, yeah.
Pi divided by 3.
Yeah, if you took pi and divided into 180, you get what? 57.293 degrees? Yeah? Stop it. Yeah, okay. So if I took that and I divided it, 57 by this, I get roughly 1 point, what? Oh, what? 5? Roughly 1.05 rads.
Or 07.
Yeah, well, we can round to the nearest
Doesn't
one.
matter. Doesn't matter
Okay.
which one you use.
Pardon me?
Doesn't matter which one you use.
No,
Okay.
I don't care. But they want radians. Now, if you gave this to me, and then you blew chunks on this one, I'd probably take a half point off. I mean, let's say it's a 10-point problem, I'm like, silly. Okay, here she got upset, or it was a bad day. But I would take maybe at the most 1 off. But be careful because Cambridge wants that radians and all that stuff. Okay? Not bad. So we got the modulus and the argument, right? Okay, and that says we have to figure it for u squared as well as u to the 3, right? We got it for you, right? Not just for me, but for you. And for this type of stuff, the total, I should have said this, let's call it the complement, right? The complement is when you have the modulus, the mod, and the argument. You have a full-blown argument, okay? And that's what's called the DMT, de Moivre's theorem, or de Moivre's formula. What is that, Murmur? Well, that's this guy right here. I know it's hard to see. And that would just be to say it's u, right? Is it not equal to what? Or z is equal to r times cosine of the angle, which you already figured out, plus I sine of the same angle. Pretty good? Not bad? Me too. It's contagious.
That's just like the standard formula.
Yeah, that is the combination of the modulus in addition to the argument in polar form. I'm already going into polar. I'm going back and forth, back and forth. All right? Well, it said, well, we need it for u squared. Well, let's do it for just u, right? Not me, but you. So that means, did we figure out what the modulus was, or the radius?
Yeah.
And that's 2, right? Times what? Now, the 2 is between both of these, right? So it's just going to be cosine of what? Let's go pi over 3. I like pi's. Pi over 3 plus I sine
Of
pi
over
over 3. Pretty good?
then
Not
we-
bad? Pretty easy. Okay? But hey, wait a minute. It didn't ask for that, did it? It asked for u squared and u3.
Yeah.
Do you have a formula for that? Of course I do. Of course I do, Sam. That's right here. It's hard to see. Okay? And if I could write a little higher, I would. But I'm going to hold off on this until you're like, yeah, we're ready. Okay. So, just going here, right? We already had u, right? Not me. And that's, or z, is equal to r cosine of pi plus I sine plus sine of pi. Okay. So that means we do the same thing. We're going to go 2 here, remember? Cosine of pi over 3 plus I sine of pi over 3. Pretty good, right? But hey, it wants u squared. That's z squared, right? And that means it's also, boom, r squared. So I'm going to take this and square it. Because whatever the exponent is, I square the radius. 2 squared is?
4.
4. Now, we have a cosine here. Hold on. and I have an I sign here. Now, it says, if I have a power, and I raise z to the power, I also raise it to r, the same power, all I have to do is use that power as a multiplier for the angle. Make sense?
The pi over
if it's-
3.
So the power in this situation, for this one is 2 for u squared, so it's a 2. So that means it's going to be a 2 here, and what was the original angle?
Pi over
3. Or,
2 pi
Billy's
over
like, screw that, I want to use radians, and she would just go 2 times 1.05, right? Okay, and now so this is going to be now 2 times pi over 3. Make sense? Let's do u3. That's z3, and that means 2 to the third, which is a good old 8. Cosine of, now Ryan just spits it out immediately, tells me it's what? Pi. Because it's 3 pi over 3, right? And those cancel out. So I'm going to write them here, 3 pi over 3, so Sophia can see it, plus I sine 3 pi over 3. Ryan says, hey, I got to make it simple for Murmur. He's hurt. So then he crosses those 3's out. Okay? Pretty good. Not bad. Yeah. Yeah. Oh, see. Awesome. All right. Not bad. Just reiterating, going over what we did yesterday.
Reiterating.
That means I'm iteration of an iteration, right? Yeah, it's like that. Okay. You remember?
Iterative formula.
Iterative formula of some fun. Yeah. Yeah. Not bad. So what you're really doing is just extending this radius and making it bigger, bigger, and bigger off of it. Okay?
Dude, part I.
That's what we're going to do, remember? Okay, and that says, I tried to give this little list here, okay? It says to find roots for this thing. And if it's a squared guy, right? You use 2 possibilities. Complete the square, which I tell you to avoid like the plague, or you use quadratic formula, all right? Can I erase this? It's okay? She's like, all right. All right, so he's like, hey, do I, double I. All right, double I. All right, so double I says, hey, it gives this to you, z squared minus 2z plus 4 equals 0. I felt like a pitcher yesterday. A pitcher that did like, a whole game for what I did yesterday, writing and so on, just this time. And then I did the boo-boo Billy. You would have yelled at me. Then I got Spencer. Anybody know Spencer Molds?
Yeah.
I had Spencer do this up for me. He's like 6'2", so he's like, just kidding it, little guy. Yeah, okay? All right, so it gives you this, and it's like, hey, find the roots. If it's a square, quadratic formula. Don't kill yourself. Instead of x, it's going to be z, right?
Yeah.
So instead of x, we're going to go z is equal to plus or minus b. Minus b, excuse me.
Negative b plus or minus the square root of b squared minus 4ac all over 2a.
4ac all over 2a. Why reinvent the wheel when it's already there, right? So now, if it's in standard form, it has to be in standard form. All the stuff on one side, 0 on the other side, right? Yeah. Well, a is going to be what? 1. B is going to be what?
Negative 2.
C is going to be
4.
4. Throw it in there. Ready? Here we go. So z, that means the roots of this thing. Most likely, if you just did the discriminant, that means this stuff right here, Mr. Tribble says. Yeah, I know that. And if this comes out to be less than 0, you know you got an imaginary friend. Okay?
Right.
Yeah, the only friends I've ever had. Next to Sam. So this is going to be minus b minus a minus 2. Make sure I plug this in correctly. Now, man gets lazy, okay? So if he has a negative and another negative, he just says it's positive, right? But I'll show the entire steps. Minus 2 quantity squared minus 4 times a 1 times a c, which is a 4. You guys will tell me I'm doing this, right? All over 2 times a 1. So far, so good? So negative times negative is positive. That's a 2. Plus or minus, yeah. That's a 4, okay. And then this is a minus 16, yeah?
Yep.
Over 2. Looking good so far? This is cake. Come on, man. You better give this to us, maybe. 2 plus or minus the square root of negative 12. Oh, hater.
I times the square root of 12.
Over. Yeah, me too. Now, I'm going to say the square root. I like chocolate cake. Okay?
Me too.
Me too. So minus 12, right? Minus 12, we're going to factor out a radical negative 1. That's an eyeball. And then we're going to factor out the real portion, which is 12. And that comes out to radical 4 and radical 3. Always pull out the largest possible square, right? Perfect square. And that's going to come out to be, what's this here? So is this going to be 2 here? That's going to be principal root. So it's going to be 2i root 3. So this comes out to be 2 plus or minus 2i root 3 over 2.
And then you just
Yep.
Then you kill out that, and you're going to get 1 plus or minus I root 3. And And that is what you got.
Oh, the kid's not.
Yeah, you cancel 2. You're too fast.
Yeah.
Boom. I'm man's remember, who would think of this stuff, right? Although there are some fantastic women. If you saw the movie Agora, I think that's the only woman I'd leave my wife for, even though she's dead for about 1,500 years.
This is on
She was the
video.
head of the Library of Alexandria. And then, of course, because of religious zealots, they stoned her to death. And then they ripped her apart. Because men are cowards, okay? And I'm not just saying it because there's a females here, but yeah, they are. Men don't want to share nothing. Yes, sir.
Everything you said is on video.
Oh, good. Then erase that. Okay? I didn't see anything negative, though, right?
Right.
So, plus or minus root 3, right? And to check, using the... See, I wish they did extreme and they gave you, like, here, this is how to do it, right? That would help. It's not like they're giving you everything. And is it plus or minus, or 1 plus or minus square root 3?
Yes, 1
Yes.
plus or minus
Good
I
man.
times the square root of 3.
That's all they wanted, okay?
Yeah.
Now, if they gave you a QB, right? We might do something a little later, okay? I'm going to do the next one. If they gave you a QB, see if you can break it up into the sum and difference of cubes. If you can't do it that way, then use the factor theorem thing. Remember, throw in P over Q? Remember we did that stuff?
Yeah.
Yes.
Yes. Sometimes what they'll say, Ryan and company, is like, hey, there's one real root, and the other 2 are haters. Other 2 are complex
They don't
roots.
like cake.
They don't like cake. You know, they're just haters. You know, they just hate the Patriots because they're successful. Even though I am a Giant fan, but that doesn't matter.
The Jaguars will beat the
Oh, you got it. You were spoken some good there. Okay, yeah. So the biggest thing is, my stepson's a Jaguar fan. Okay, so the biggest thing is where the heck was I? Oh yeah, about roots and so on. So if you have something that says there's one real guy and 2 other guys that are complex, throw P over Q in there until you get a 0, and then break down the cubic into a quad, and then keep going from there. Sometimes use synthetic division. Okay, we're going to do one hopefully in a couple minutes. All right? We're going to do part 3. As you can see right here, I have it on the book. All right, any questions how to do this? Now, yes, if you are that interested, I can do complete the square for you. Okay, I can show you how to do it, but everybody's like, they don't like complete the square.
I actually like that a lot more than synthetic.
Or quadratic.
How does complete the square help you get roots?
Oh,
Like, that's the vertex.
Oh, it does everything. You use complete the square even if you wanted to get this guy right here. Okay? The complete the square is even older than the quadratic formula, which is, in my opinion, over 4,000 years old. Easily 4,000. Easily. Okay? If you wanted to, Mr. Tribble's like, well, throw the constant to the other side, right? And then use your B over A, right? And then this becomes Z minus 1. And then factor it up. You want me to do it? Let's do it. Okay? Rock and roll. Let's see if I do it right, Mr. Tribble, okay?
Because I hate the quadratic formula.
Okay, so Mr. Tribble's like, hey, I'm going to subtract 4 from both sides. Good. Z squared minus 2Z equals negative 4. Now, okay, not bad so far? So now you're going to say to yourself, that's the B term. I'm going to take half of it. Yeah, I'm going to go Z minus 1, and I'm going to quantity squared equals minus 4. Now, to balance it out, I always say to myself, because it's B was minus 2, right? And B over 2 is equal to negative 1. Now, B over 2 quantity squared is a good old 1. So what I do is whatever that value is, it's always going to be positive. I take it to the other side and balance it out because it's going to be a constant here. So I'm just going to add 1 to that side right there. I add 1 here, 1 there, and then it gets absorbed, right? So then Mr. Tribble goes, well, that's Z minus 1, murmur. He's right. Is equal to minus 3. Looking a little better? And then he's like, all I do now is, hey, I can solve for Z. I take the square root of both sides, and I get Z minus 1 is equal to, well, if I take the square root, how many possibilities are there? Plus or minus, absolutely ends, and that's plus or minus square root of, remember there's a minus 3 there, so we're going to minus 3. And now I just add 1, and now I just filter this out and make it 1 plus or minus I root 3.
That's beautiful.
And he gets a big old happy Sammy
Where'd
kid.
the I come from?
Because it's negative inside the radical.
Oh, it's in the I didn't see that.
Yeah, because originally there was a minus 4 there, right? So Mr. Tribble, he does it a little faster. There could be more errors associated with this, but there's the
I feel like there were errors with the quadratic for me.
yeah. Some people don't like the substitute.
I don't like the
Formula.
I leave that up to you.
I love
Okay,
quadratic.
what method you wish to use.
Okay.
All right, just go to 3i, right? Now, it says, all right, so this one I had to struggle with because I've never seen some of the way they're talking about this, and I spent some time on it. So it says, hey, it says z minus 1 absolute value, right? It's greater than or equal to 1, and it says this. So it wants us to find the inequality, I believe, yeah, that satisfies all this stuff. Well, the first thing, I wrote some stuff up here as well. You're going to try to find out the circle, okay? For some reason, if there's a circle of a tremendous, infinite amount of points on the imaginary complex scale. And that I used is z minus z1, which is right here, which is r. Now, inside here is going to be the radius, excuse me, it's going to be the center. We're going to follow that in a second. And then here is the radius, okay? So there's going to be an infinite amount of points inside the circle. If it's less than or equal to, it's everything that's inside that thing, or that circle, or that object. If it's greater than or equal to, that means it's everything outside, and the border, it's counted as a solution. If it has this now, that means, guess what? This circle now is be dotted, okay? Remember your inequalities? Yeah, well, they're coming back to haunt you, okay? So if it doesn't have the friend, it's jaded. That's how I always tell students, okay? If it's greater than or less than, whatever the solution is, like the line or whatever, the line's dotted. For the circle, if that's not there, then that circle is dotted. Does that make sense? Because you're not including those values, okay? It's everything up, it's like an asymptote. It's similar to it. All right, so now I have this here, and then I said to myself, oh, okay, so here, see that z right there? Yeah. Well, I know that z equals x plus yi. Well, what I do is I substitute x plus yi right there, minus the little eyeball that's associated there. Make sense so far? Yeah? Not bad? Now, some people say, like, well, they know what z is, and then so on. Well, if you recall from conics, you're going to have something like this thing. Remember you had the circle, and had the center, and the radius, and all that other jazz? Well, x minus h squared plus y minus k quantity squared equals r squared. And if I square rooted that beast, I would find out what the radius was, right? Well, it's already inside here. So all I have to say to myself is, well, I factor, right, a common thing here, which is a minus 1, y minus 1, and then the x here. And then, see, I'm a little lazy. Since I know that this is going to be absolute value because of these bars right here, I know that I'm going to take x, whatever that value is, and square it, and y, whatever that value, and square it. So there's nothing with the x value, right? X minus 7. So I don't have to square it. So I just know it's just going to be good old x squared. Because remember, it's a magnitude, right? It's a value, right, for the equation. And y minus 1, I know I'm going to square that thing right here. Make sense so far? Yeah? Yes, I'm listening.
Where'd the eye go?
The eye got absorbed, so to speak, because the eye is still there, but it's on the imaginary axis.
Okay.
Okay, that's a good question. But they're really lazy. They don't write it. And see, it disappears here, and they put it in front or whatever, but they're just lazy on that notation, okay, from what I found. So now I have x squared plus y minus 1 is less than or equal to 1. Well, that still says the radius is a value of 1, right? Yeah, hold on, yeah.
Wait.
Yeah.
The step that you had, the x plus y minus 1 times I.
Yeah.
Right?
Now I know it's a magnitude. So all I say, I did a real shit.
You just
Square it. Because of recall of this. See this? X squared plus y squared is the magnitude.
Doesn't that not
Well,
work?
I know that inside here, well, I try to prove it here. I said x plus yi and then this stuff right here. And in order to do this, because of these bars mean to be what? It's a magnitude, right? So each of those things gets squared.
Yeah.
So that means this guy gets squared and this value gets squared as well to find the center.
Oh, like a magnitude of...
Yeah, just like from conics, right?
So you don't square what's out on the other side.
Now, if I had an x plus 3 there, then I would take that in quantity squared, right?
Yeah, but on the other side, it's less than or equal to 1, right?
Yeah, I leave that alone.
You're
I
not
don't. No,
squaring that.
I don't have to square that. No.
Okay.
No. Okay. So now what do we do? We have x squared and y minus 1 here, right? So if I set these equal to 0, x equals 0, boom, that's 0, right, for the center, and then y equals. Now it's an I there, right? So it's a location. So it's at 0 for x and the real thing, and it goes up 1, right, on the I scale. It'd be like 0, 1, right, in the real number system, but it's 0, comma I.
Why are you making x 0?
Because x is 0 because it says I don't translate anywhere from the origin.
Is doesn't have a minus.
Because there's no.
Why is that
Zach,
squared?
where does
Oh,
it
well,
say?
hold on. It's all right. You can yell at me.
Where does it say
So I'm
that?
trying to teach
No.
it. Now go ahead. I'm listening.
Where does it say
Where does it say?
that we set x equal to 0?
We set x equal to 0 because we want to find out where the center is. If you remember to translate graphs and everything else, if I had, for example, I don't know, x plus 7 squared plus y minus 3 squared equals 20. Well, where's the center?
It's
Change the signs. I said each one of those those portions equal to 0.
Negative 7, 3.
Negative 7, 3, right?
'Cause it's
Because it's
each thing.
translated from the origin.
So there's nothing. in-
There's nothing to translate from. It's not moving from the origin. It's not going windage or windage.
Okay.
Windage.
I thought we
Windage.
were
Right.
plugging in, like they gave us
Yeah.
x equals 0, plugging it
No,
in. But no,
no,
we're setting it
setting
to 0
zero.
to solve
Yeah.
as we
Yeah,
would do.
yeah,
like that.
yeah. So the center is 0, I or 1I. So that's where the center is. And the z, it was already told me it was what? 1. So far so good? And it said, hey, shade that region wherever it is. Well, it's a circle, right, that has a radius of 0, 1, so to speak, 1I, and a center of 0, 1, and a radius of 1. Well, there's my cheesy picture, yes?
But you don't know where. Well, I guess you could say it's between 1 and 2. somewhere
Well,
between.
I could,
Well, it should be anyway.
I feel so awful doing this. So something like this, right?
Oh, it's 0, 1.
You know, let's say it was here, right? Well, then this unit is a 1, right? And that's a 1 there, and a 1 there, and a 1 there, right? You would move it 1 unit to the left, 1 unit
Right.
to the left, subtract, 1 unit to the right, add, 1 unit, add, subtract.
So we ignore I because on the graph we're using, the vertical axis
Yes,
already has
yes.
1I, 2I, 3I.
Yeah,
Okay.
yeah. Now it said, hey, since I told you it's less than, right? I think I wrote it. Since it's less than 1, shade the inside, and I shaded it with purple. Shaded it with purple.
So if it was
Because it's
greater than-
powerful. The
we'd
Romans
shade-
thought power. Purple.
We'd shade everything else.
Yeah, if it was greater than, it'd be all this stuff outside the circle.
What exactly is the RC?
I'm going to get that in a second.
Okay.
Okay. Well, you want me to do this one? Okay. They're asking me a million questions on this, and that I understand. And this is just like 1,000 points? No. How many points was this one?
4.
4. All right, that's 3 right there. Okay. And then the last one's just an argument. All right, it's an arg. Yes, sir.
So some of this just formulas that are repeated, or would we need to write all of that for?
You would need to just do this portion right here. Okay? And then the graph. Okay?
Uh-huh.
Because that's what it asked for.
Yeah.
He's like, just give me the bare bones. You got it.
So the Argand diagram is just a circle on the imaginary.
Beautiful.
So Argand diagram is just
She put her on full time.
Thing.
It's the graph, right? It's the graph.
a
Yeah.
graph, but a
I was-
line. It's an imaginary
Yes.
graph.
Yes. It could be a picture. It could be a triangle. It could be a bisector. It could be anything, right?
Imaginary.
Okay. Usually they like all these circles. I'm always struggling to make the pictures. Okay. And I'm going to try to do. How much time we got? Not enough, right? 10 minutes. All right, now that's okay. Now it says, hey, what about the arg argument? It says the arg of z is greater than or equal to the arg of u. Well, the arg of u was what? By that angle, right? We already figured that out, didn't we? It was pi over 3. Yes. Remember that? Remember that a long time ago in a story,
Oh,
Galaxy
yeah.
Far, Far Away?
Yeah.
The arg of u. Remember, it was the tangent of -1 of y over x.
Yeah.
From u, remember? It came out to, Billy said, hey, it's 1.05. Okay, you're right. And Sophia's like, no, it's pi over 3. Oh, okay, fine. I'm not going to argue between two women. No.
60 degrees.
6 degrees, right? So now, all I got to do is figure out the arg of z. Well, the arg of z, I use the center point right here, which is 0, I, right? Which is 0, 1. That makes sense? So remember, here we go, 0, let's just say 1i. Is that okay? So that's my x. Oh, my goodness. And that's my y. Right? So all I have to do is put them in here.
Arctan of 1.
Arctan of, yeah, beautiful. Arctan, principal angle of tangent of y is undefined. And I think that's what it said here. Did I have it the right way? Yeah, I just didn't put this the right way. One's undefined, one is a value. So undefined means a value any day of the week.
If there was an x value, but no y value, then you would end up with a 0 in the denominator.
Well, how about if I had it
Because
just
there'd be
as,
no imaginary number.
that's, yeah. There's that Netflix.
Pardon me, Mr. Murmur.
Yes?
Can I see Billy Fretwell in the front office?
Of course.
What were you doing?
I don't know. They just, I
I
just do what they tell me to do. All right, so let me go back to this again. You already had the arg of z, or arg of u, not me, you, right? And then you have the arg of z. Well, the arg of z says it's just going to be 1 over 0, right? By using those 2 points for the center.
It's 0 over.
What's 1 over 0, which is undefined, right? It's
Okay.
a billion or zillion or whatever, right? So that defeats or beats up the other guy. Pretty good?
Yeah.
Not bad.
So the undefined symbol is the little O
0 with
with
a
the.
slash.
Because
Yes.
Miss K was saying
Empty
that.
set.
Yeah.
Empty set. It's undefined as well. It's indeterminate as well.
They mean the same thing, though.
Yes.
She said that null set is not the same thing as undefined.
All right. If we were in a 400 level, 500 level math class, she's right. But here, you can get away with it. Okay?
She told us not to use it, but that's my.
She would probably just do something like this, right?
She wrote say no
Just say-
solution.
No, and that's fine too. NS is no
Or just
solution.
write undefined.
Or undefined.
Oh yeah.
Okay? But mathematicians get lazy. All right? And give you this stuff. All right? And if you take a look, it says what? All right? Show the points correctly in the Aragon diagram. Check. Show the right circle. It says the relevant circle. Like I'm going to show an irrelevant circle, right? Yeah. And then it says show something else, the correct region, and then that's it. Okay? So it took me a little while to do the Roman numeral 3. Okay? Not bad? Pretty good? Yeah. How much time left? 5? All right, so I'm going to stop right there, not to torture you. I recommend looking over, I would look over the 2010s and so on. Remember, they're all over 8Mundo, all over the place.
Yeah.
All the answers are there. So you know that, like, well, I just pick one of them and say, hey, I guess I'm going to do that one, okay? But if you want, I'm going to try to pick another one. You know, I mean, we could do every single one of these, but I'm going to try to pick another one that's on this sheet here, up to 2009. And then you guys are going to bug me and say, hey, do one from 2010 to 2015. Okay? Not bad? So I recommend sometime tonight, just look at any one of them, like just pick one and look at it, and then like, oh my goodness. And then you can bug me tomorrow, like, hey, will you please do these? And then I'll try. All right? All right, any questions? Not bad today? Not bad. Yes, Mr. Rock.
So this is for a grade, and this is just practice.
This is practice, but I can also take any one of these and put them on there. But I'll tell you which ones I like, okay? I'll tell you like my top 10, and I'll probably do like 4 or 5 on the test. And then I'll tell you, Mr. Epler as well, from 2010 to 2015, the 3 or 4 I want you to work on at home or wherever. And maybe I'll give you some extra time to work on here as well. Remember, we're going to have the test tentatively on Tuesday. Okay? Yes.
So we don't need to do all these for homework?
I would be in love. But yeah, you don't have to do all of them. Okay?
So like you're going
You
to
can do
select.
as many as you wish.
Okay.
As many as you wish.
Okay.
Any other questions? Pretty good? I mean, I had to do all of them because you can come up and say, hey, I want you to do this one, right? I mean, I'm looking at right now, just for fun, May, June 2007. I'm going to do one tomorrow. Just remind me on the word conjugate. Do the one regarding conjugate. Okay? All right. All right, that wasn't bad.